Hello friends, let us begin the double integration. So we studied the integration in our 12th standard. So let us recall that part first. So basically integration arose from the area under the curve. Suppose you have this is curve. So y equal to fx. And we would like to find out the area under the curve between the points say A and B. So what we do here is we just break the interval A to B into subinterval like x0, x1, like interval A to B. Let's say here we write x0, we write xn, so x1, x2, and so on. And we take one point here, say x1 star, same way x2 star, x3 star, and so on. And the value, this is the height. Height is nothing but fxi star. And width, this width is we call as say delta xi. And the first rectangle, the area of that rectangle is f of xi x1 star delta x. Then second rectangle area is f of x2 star delta x. And nth rectangle. And we add up all these things. And we say that that is the approximate area under the curve y equal to fx from A to B. And if we take this rectangle, number of rectangles, more and more, like number of rectangles tends to infinity. And then this area, that is nothing but the integration A to B fx dx, and that gives the area under the curve y equal to fx from A to B. So that was the concept in integration. Now the same concept here for the function of two variables. So here we have region like AB cross CD and the function f of xy. Let us time being assume that that is a greater than or equal to g. So we have that surface, and so here we have that surface, and we have the on x-axis we have the AB, y-axis we have CD. So we have like this AB cross CD. So instead of this kind of sub intervals, we have like this. Okay. So we have like this. So we call this is x0, x1, x2, xn, y0, y1, y2, yn. And this is one small square. And we take one point inside xi star, yi star. And then we take the value of the function. That is the like this. So we then erect that and we find out volume of that part. Okay. So that is the volume of one, and that we have say suppose n, and then as n tends to infinity, so we find like f of xi yi star, that is height, and delta A is nothing but the area. Okay, like this area of this. And so here we have two sum, like summation I equal to 1 to n and j equal to 1 to n, because we have AB cross CD here. So that gives us the volume of that surface. So we approximate volume of that surface is like this. And as this number tends to infinity, and we take that limit, that gives us the double integration. So this is the idea behind the double integration. So we can solve some examples of double integration. So first we take the kind of examples where we have double integration fxy dx dy and limits are constants. Say suppose x from a to b and y is from c to d. This is same as y from c to d, x from a to b, fxy dy dx also. So let us take the example like evaluate the double integration 6xy square dx dy where x equal to 2 to 4, y equal to 1 to 2. So let us evaluate double integration 6xy square dx dy and x is from 2 to 4, y is from 1 to 2. So when we integrate with respect to x, y will be considered as constant. So this is a 6y square, y is from 1 to 2, and integration of x is x square by 2, and x is from 2 to 4. So this is a 3 here, y is from 1 to 2, y square. Now x is 4. So this is 4 square minus 2 square. This is dy. And so this is now 16 minus 4, 12, 12 and 3, 36. Y equal to 1 to 2, y square dy. And so this is 36, y power 3 by 3, 1 to 2. So then this is 8 minus 1, 7 and 12. So answer is 84. Let us take one more example. Evaluate double integration x square y square plus cosine pi x plus sine pi y dx dy, where x is from -2 to -1 and y is from 0 to 1. So here double integration from -2 to -1, 0 to 1, x square y square plus cosine pi x plus sine pi y dx dy. Let us integrate with respect to x. So then y constant, integration with respect to x cubed by 3, then integration with respect to x, integration of cos, so it is sine pi x, and divide by derivative of pi x is pi, plus this is sine pi y is constant, integration is x, and x is from -2 to -1. So this is equal to integration 0 to 1. This is y square by 3. Now x is -1. So -1 cube is -1. And minus x is -2. -2 cube is -8. So minus minus plus. Plus 1 by sine pi x. So x is -1. So sine minus pi. And sine minus pi is 0. X is -2. So sine minus 2 pi. So that is also 0. Plus sine pi y. X is -1 minus and minus minus plus 2 and dy. So this is equal to integration 0 to 1. This is 7 by 3 y square. This is 0. This is 1 plus sine pi y dy. And so this is 7 by 3 y cube by 3 minus cosine pi y, derivative of sine is minus cosine pi y over pi, and y is from 0 to 1. So this is now 7 by 3, y is 1, so 1 by 3, then minus cosine pi by pi, and lower limit 0, then this is 0, then minus cosine 0 by pi. So this is 1, this is -1. So this is 7 by 9, minus minus plus 1 by pi, and this is also minus minus plus 1 by pi. So 7 by 9 plus 2 by pi. Let us take one more. Evaluate double integration x e power xy dy dx, limit of y is from 0 to 1 and x limit is from -1 to 2. So here 0 to 1 -1 to 2 x e power xy dy dx. So let us integrate first with respect to y. So that is -1 to 2 x constant, integration of e power xy is e power xy divided by derivative of xy with respect to y. X is constant. So like e power 5y. So it is e power 5y upon 5. So e power xy upon x. And y is from 0 to 1. So this x cancels. And y is from 0 to 1. So this is e power x, y is 1. Minus y is 0. So e power 0 dx. So this is 1. So this integration -1 to 2 e power x -1 dx. And so this is nothing but e power x minus x from -1 to 2. And so now this is e power 2 minus 2, then minus e power -1 minus -1. Okay. So this is equal to e power 2, then minus e power -1. This is -2, and this is again -1. So -3. This is the answer. Next video, we shall take the examples where these limits are not constant, but variable limits given. Okay. Thank you.